Problem 13, given that 9gx plus 4x sine gx is all of this and g of 8 over 7 is 0, find g prime. Okay, it seems rather complicated and I seem to have found an answer. How so? Well, g prime, so that tells me derivative with respect to x. So let's go through each step. Derivative of this is g prime plus derivative of this. Notice there is a product rule there. Derivative of the first, second as it is, plus first as it is, derivative of the second. This calls for chain rule. Derivative of sine is cosine, inside object as it is, times derivative of the inside object, equals derivative of this plus derivative of this, and derivative of this is 0. Now plug in x equals 8 over 7. We are told g of 8 over 7 is 0. Okay, so I need to use both material. 8 over 7 for x, 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 8 over 7 for x. So where did this 0 come from? It's g of 8 over 7. That is 0. Likewise, g of 8 over 7 is 0. What do we know about sine 0? That's 0. So this term goes away. What do we know about cosine 0? That is 1. So that term survives. Okay. So 9 g prime 8 over 7. And what is this? 4 times 8 is 32 over 7. G prime 8 over 7. So these g prime 8 over 7 shows up in these two terms with coefficient 9 and 32 over 7. That's what this is. Right hand side, I have simply substituted x equals 8 over 7. So whatever that is, 7 goes in 56 8 times. 64 plus 17, that's 81. G prime 8 over 7 is 81 on the right hand side over whatever this be, right? So 81 over 9 plus 32 over 7. Next problem. Given this relation, find dx over dy. Notice it is x over dy. In other words, I am taking derivative with respect to y. So you have to think of y as an independent variable. So derivative with respect to y of both sides. So this is power rule followed by chain. So 2 comes down, power reduces by 1, and then you go in. Remember, I'm taking derivative with respect to y. So this gets me 2x dx dy. This gets me 2y because I'm taking derivative with respect to y. So same variable, I don't need dy dy. Right hand side, this is product rule. I've written the 10 outside. Derivative of the first 2x with a dx dy, second as it is, plus. First as it is, derivative of the second is simply a 1. Get the dx dy together, resolved it. So 2x times 2 is 4x. All of this dx dy plus this times this 4y, all of this equals 20xy dx dy plus 10x squared. Get dx dy together. So move this guy to the left, move the other guy to the right. All of right hand side divided by the factor. So all of right hand side, so that's your big parentheses over big parentheses and fill in carefully. All right. Next problem, you want to find equation of the tangent line. So you need dy dx. You're given point and you're given equation, find d by dx of both sides. Derivative, 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 derivative. Right hand side is 0. I'm simply using derivatives. Mind you, this calls for product rule. Product rule, that gets me these two terms, and this is the standard derivative. You go through all this process, you get dy dx expression. At this point, remember your point, x coordinate is 4, y coordinate is -4. Plug it all in. I get derivative. Substituting, resolving, I get 1 over 4. Use that as the slope for the given point. Okay. Simplifying, I get slope-intercept form. Okay, they have not told me how to, so I'm simply using slope-intercept form. If it doesn't work, then I will try standard form. Okay, but right now let me try slope-intercept form. 1 over 4 is the slope. I'm writing it in parentheses times x minus 5. All right, so the equation, oh, of course, they want an equation of a line. So y equals all of that. That's an equation, okay? All right, so you understand. I hope you figured out. I cannot just give an expression. I need equation of a line. So that completes my section 2.6. Next videos will cover section 2.7. Until then, bye.